I have one very short addendum to the convolution theorem. Remember that the convolution theorem says that if you take the Laplace transform of a convolution of two functions, you get the product of the transforms. So if you were to take f of t convolved with g of t, you end up with the product, capital F, times capital G. And one consequence of the convolution theorem is the following. This is item number 34 on the Laplace transform table, but one of the consequences is that if I were to take the Laplace transform of an integral, and I would take the integral from 0 to t, f of y dy, how could we do that? Well, we don't really need to do much work. We don't need to work that hard at all if we recognize that this is just the Laplace transform of 1 convolved with f of t. Okay, so this is, I shouldn't write it like this. This is 1 convolved with f of t. And so this is going to end up being the Laplace transform of 1 times the Laplace transform of little f. And the Laplace transform of 1, this is the first one that we talked about. This is 1 over s. And the Laplace transform of little f we write as capital F of s. So it turns out that the Laplace transform of an integral f of y from 0 to t is going to be f of s over s. Again, this is item number 34 on the handout.